average velocity, but first I just wanted to talk about what average means really quick before we dive into looking at it in terms of physics. So I presented you with 3 different test scores here, test scores you may have had in class, and these are all out of 100%. So on test 1, 80%, test 2, 75, and test 3, 70%. So the way that we get the average is we add up all the scores, as you can see over here, 80, 75, and 70, and we add them up until we get a score of 225. So our total of 225 would then be divided by 3. Well, those 3 come from these 3 tests. We need to divide by that to figure out what our average was over all those tests. And it comes out to 75%. So if I wanted just a single number, a single snapshot of all 3 of these tests, my average would come out to be a 75%. So it's this idea of taking something that has happened over a duration of time and condensing it down into one single number. All right, so what does this mean in terms of velocity? So if we're looking at the velocity of an object over a given period of time, I always like to use the analogy of a long car ride. If you've ever gone anywhere in a car, like a long trip, you're always looking at your average velocity. So an entire car trip would involve leaving your house, driving down a couple streets, turning, and then maybe here's your highway that you get on, and then once you get on here, you start driving at a typical speed of 65 miles an hour. Miles per hour. That's a unit that we're all familiar with. It's actually not a unit we use a lot in physics, but for understanding average velocity, we're going to start with that. Now, to think that once you get on the highway that your average speed of the trip is 65 because that's what your speedometer is reading is actually not the right thing to think, because you went through all these roads here, say that this is Dempster here and you're on your way out to 94 to go up north. Well, the whole way out there you were not going 65. You were going maybe 30. Then maybe here you were going 25. Then here you were going 30 again, and here you're going 20. And then finally getting on the road and going 65. So at this point when you got on the highway, your average velocity would actually be below 65 miles per hour. It's the same train of thought that if you had a bunch of test scores and on the most recent one you got a 90%, but on every single one before that you had a 60, 70%, you wouldn't get a 90% and then assume that your test average is 90%. Well, average velocity works that same way. You have to look at the duration. You have to look at the single number. So if we put this kind of into an actual physics problem, and we'll start off kind of easy. Let's say that you drive. Let's say that you're driving 30 miles per hour for 1 hour. Then you drive 60 miles per hour for 1 hour. Real simple here. What must your average velocity be? Well, you know that you had a speed of 30 miles per hour, and then you had a speed of 60 miles per hour, and I can just add them up really simply on top of each other because we have the same amount of time here. And that's a really important thing to understand and keep track of. So that comes out to 90, and we need to divide that by the 2 numbers that we have here. So that's going to come out to an average velocity of 45 miles per hour. So even when we looked at the end of this, you would have been going 60 miles per hour. The average velocity over that trip was 45. Now, another good way to think about this is think about a speed trap. When a police officer might be sitting on the side of the road with a with a radar gun trying to get the speed of cars going by. Now, if you were sitting at and excuse my really poorly drawn car, at a stoplight here for 1 minute, but then in the next minute you were going 40 miles per hour, and here you were going 0 miles per hour because you were stopped, and the speed limit was 30, and the cop sitting here with his speed gun clocks you going 40 miles per hour, in that instant you would be speeding because he would get you going exactly 40 miles per hour. Because cops don't use average velocity, they use instantaneous velocity, which we're going to talk about later. So if you were to take the average velocity of this, you would have to add 0 miles per hour plus 40 miles per hour, because you were here for a minute and you were going 40 for a minute. And since we have two numbers that we're using here, you'd have to divide that by 2. So your average velocity was actually only 20 miles an hour during that time. So your average velocity was under the speed limit, but your other velocity, your instant velocity, was over. So hopefully that helps you kind of understand what average velocity means. Kind of revisiting back up here really quick, it's taking all of these numbers that are that happened over a duration of time and combining them down into one average number. So that is the basics of average velocity. There's a lot more to it, but this is a basic introduction. Thank you, and I'll see you guys again.